So to demonstrate how to run the belt latch interval to show different numbers of parts per minute, what I did was I created a process manager. So this is running PackXpert. And if I go into the part, so the part basically defines what is coming on the infeed belt. So if I open up part, you can see that I had created that as a belt latch. So I've defined that as a belt latch. And if you go through the setup software or through the setup wizard, that'll walk you through that process. The other thing I did was I created a box to represent a part, and I just linked that box shape to the incoming part so that when parts are coming down the conveyor, rather than just seeing a little dot, you would actually see what looks like the part. Now the key to this is really in this part belt. The part belt gives two things. It'll give you the ability to set the speeds of the belt, and it will also allow you down here to set the latch period in emulation mode. So what is that distance between the parts? So in a case where you know the part spacing, you can simply put that in. So if you want to try and figure out what kind of parts per minute can the system actually run at, then you need to adjust your belt speed accordingly. So if I open up a spreadsheet that I have here to show as an example, I simply just created this little quick calculator. So it takes the product interval, it asks you what the target parts per minute is, and based on the target parts per minute, it'll give you a cycle time. And then using the cycle time and the product interval, we can figure out what the belt speed should be. So for instance, if our product cycle is, say, 20 inches, or product interval is 20 inches, then our spacing is 508 millimeters. That's just 20 times 25.4. That's just inches to millimeters. And then let's say we want to see if we run this at 45 parts a minute, that's going to give us cycle time of 1.33 seconds. So our belt speed would need to be 381 millimeters per second. And if you see the math up in the cell, it's just the product interval divided by the cycle time. So now if I come back into the belt area and I change my speeds to be 381, and I'm lazy to try and remember exactly which one is the fast and which one is the slow when they run. I believe it runs on the slow, but by default I just typically will go in and set them both. So now I can run the process, and now you see parts coming down, and you can see it going and running that routine, and the robot is plenty fine in terms of keeping up with the cycle rate. So now let's change this. Let's stop that process. We'll come back into the calculator. Now let's try and set it up to 60 parts a minute. So at 60 parts a minute, our belt speed would need to run 508 millimeters per second. So we can come back into our speeds here, do 508, and then 508, and then we can run. And now we should see the product's coming just a little bit faster. So now you can see the robot's definitely working a little bit faster. And that kind of gives you the idea of how to set up that timing. So if you want to change the timing for kind of estimating what a cycle might look like, using the latch as a means for playing with your cycle time and then calculating what your product interval is and what your belt speed is, using this simple calculator is a great way to do that.